Welcome to the explainer. Every developer wants to ship code fast. But what happens if that speed introduces a critical security flaw that costs your company millions? Today, we're going to break down how to build a pipeline that's practically unbreakable, one that ships confidence, not just code. Let's just start with the reality of what's at stake here. This quote, it really gets right to the heart of it. A single, tiny crack in your app's foundation can end up exposing your user's most private data to, well, everyone. It is a developer's worst nightmare, plain and simple. Think about a classic devastating attack like a SQL injection. An attacker can use a basic web form, something your users see every day, to inject some really nasty code. And just like that, they've turned your own application against you, and they could walk away with your entire user database, all because of one little flaw. And that brings us to maybe the most important point of all. When you find these cracks matters a lot. And as you're about to see, waiting until your app is live and in production, that's not just a mistake, it's a disaster that's going to cost you a fortune. So, to avoid that disaster, we have this really powerful concept called shift left. See, traditionally, security was like this final toll booth at the very end of the road. Shift left completely flips that on its head. It's all about moving security from the finish line to the starting block, giving developers the power to spot and fix issues the second they write them. So what does this actually look like in dollars and cents? Let's break it down. When a developer is in their flow, writing code, fixing a security bug is pretty straightforward. On average, it costs about $80. It's just a quick fix, part of the job. But what happens if that exact same bug slips through the cracks and makes it out into your live application? Well, the cost to fix it just explodes. We're talking over $7,600. And that figure doesn't even touch the all-hands-on-deck emergency meetings, the developer overtime, and the potential damage to your reputation. Just look at that chart. It's not even close, is it? We're talking about a nearly 100 times increase in cost. It's the difference between a little course correction and a full-blown 5-alarm fire. This is exactly why shifting left isn't just some trendy buzzword. It's just smart economics for any team building software today. So, the big question is, how do we actually shift left in a practical, day-to-day way? Well, that's where this whole idea of DevSecOps comes into the picture. Now, I know what you might be thinking. DevSecOps, it sounds complicated, like it's just going to add more red tape and another security department to argue with, but it's actually the total opposite. It's about making security everybody's job and baking these automated security checks right into the CI/CD pipeline that you're already using. The end goal here is to build a system where going fast and being secure aren't fighting each other. Think of it like a Formula One team. You want that car to be blindingly fast, right? But you also need the brakes, the roll cage, and all the safety gear to be absolutely top-notch. It's all about creating the fastest and the safest way to get your code to production. All right, so the theory sounds great, but how do we actually build this thing? Let's get really practical and look at a toolkit with 3 specific types of tools that will give you total coverage for your pipeline. Okay, first up is Sonar Cloud. This is what we call Static Application Security Testing, or SAST. The easiest way to think about it is like an expert proofreader who's looking over your code, checking the actual blueprints for any weak spots before you even start to build. The really important thing to get about a tool like Sonar Cloud is that it focuses on the code that your team actually writes. It'll find everything from messy code smells that make the code a pain to maintain later, all the way to critical security holes like a password that's been hard-coded by mistake. It's your first line of defense, securing the foundation of your app. So Sonar Cloud is watching your code. But what about all the code you didn't write? Well, that brings us to our second tool, Mend. This is a software composition analysis, or SCA tool. So if Sonar Cloud is checking your blueprints, think of Mend as the quality inspector for all the third-party parts, the bricks, the wiring, the plumbing that you're using to build your application. And this is absolutely huge. Most apps today are built with over 80% open source components. That means a vulnerability in some library you've never even heard of, like that infamous Log4j disaster, suddenly becomes your problem. Mend scans that whole software supply chain and flags any of your building blocks that might be compromised. And that brings us to our final layer of defense, OWASP ZAP. This is a dynamic application security testing tool, or DAST. So up to now, we've checked the blueprints and we've inspected the materials. Now the application is actually built and running. Zap acts like a professional penetration tester that you've hired to actively try and break in from the outside. It literally attacks your application just like a real hacker would. It's looking for weaknesses like insecure server settings that you can only find when the whole system is up and running. This is that final, crucial check that makes sure all the different pieces, your code and all your dependencies, are actually secure when they're working together in the real world. Okay, so let's put it all together now. What does this actually look like in practice? How do these three tools work together to create that complete secure pipeline we've been talking about? Well, what you end up with is a series of automated security gates. It looks like this. First, a developer writes their code, and they get instant feedback right there from Sonar Cloud. Then, when the app is built, Men jumps in and scans all those open source libraries. Finally, once it's in a test environment, OWASP Zap attacks the running app. And here's the most critical part. If any of these gates finds a serious problem, the pipeline slams to a halt. The build fails. Only secure code gets the green light for production. And that really brings us to the question you've got to ask about your own process. Yeah, your pipeline is shipping code, but are you sure it's also shipping confidence? Because in this day and age, a great pipeline isn't just about being fast. It's about building trust with your users and being able to ship with total confidence every single time.